Welcome back to the mini lecture on glacial ecosystems. We're now going to move to the exercise component of the course. And here I thought we could look back a little bit more at this subglacial methane emission and use a little case study to see, to combine a few of these mechanisms that might be happening under the glacier. So here we're going back to a study that was done in Greenland, looking at methane emissions from beneath the Greenland ice sheet. So on the left, we can see a difference in methane concentration. So the details of the figures are not that important, but in short, what we managed to do is over a whole melt season, we could see variability in concentrations in the river exiting the glacier. We're also monitoring how much water is coming out of the ice, how much sediment is coming out of the ice. And a question is like, could this abiotic hydrogen that we talked about during the lecture, could it potentially be fueling some of this methane that we're seeing emanating from the ice sheet? So I'll leave you guys a few seconds to read the text. And don't worry, there's a summary coming up. So if we move on to then a little recap on this subglacial crushing. So, and you have a little bit a closer look at this study. So we know from laboratory experiments that crushing of silicate mineral, so similar to what we are expecting to find beneath the Greenland ice sheet, when we crush them under cold conditions and control conditions, the study have found that roughly 11 nanomole of hydrogen gas can be generated per gram of crushed mineral, or sediment in this case. If we then look at one of the metabolism that can produce methane, this time using inorganic produce. So I don't know if you remember, methane can be produced from different ways. So using organic carbon, but also using carbon dioxide and hydrogen gas, like in this example here. So you know that methane is generated in a 4-to-1 ratio with hydrogen. So you need 4 moles of hydrogen to generate 1 mole of methane. And so going back to our little Greenland experiment, and if we assume that all of the sediments that are being exported, that we're absorbing, being released from this river, have been generating some of this hydrogen through this mechanism, how much of this hypothetical hydrogen potentially could be supporting the methane that we observe? So is this reaction producing enough hydrogen basically to match the methane that was exported? So on the left here we have the summary. So overall we let's say we observe 6 to 10 milligrams of methane. We know that the overall water that came out through the whole summer was 1.5 cubic meter of water at an average sediment concentration of 1 gram per liter. And we're assuming these rates that are described here. So 11 nanomoles of hydrogen produced per gram of sediment through methogenesis. And you might also need to know the molar mass of methane to do a little calculation. So I will leave you guys a few minutes to think about this.